Okay, so we want to find the area of the shaded region, and let's do it by left-hand sum. Left-hand sum. Okay. Okay, so this is a little bit different. The delta x is this time not 3, but because the length is 2, is 2 over n, right? Now the initial height. So let's say here's your first region. Is taken at 1, and then it's taken from 1 plus, this will be 1 plus 2 over n, right? And then next one will be 1 plus 4 over n, right? So this is what it's going to look like, right? F at 1 plus f at 1 plus 2 over n, f at 1 plus 4 over n, all the way to what? F at 1 plus 2 over n over n, right?
Yeah.
2 over n minus 1
Yeah, I forgot the minus.
over n. Okay. All times that by delta x, because these are the heights, and we have to multiply by the base to get the area of the rectangle. So then our area is going to be limit n approaches to infinity, I is from 1 to n, right? And it's the function 1 plus 2 I minus 1, right? 2I minus 1 over n. Okay, 2I minus 1 over. That's the key difference. And also the key difference here is this 1. Before we didn't have this 1. It was 0, right? Okay. So now that's under the function of whole thing squared. Right? This whole thing has to be squared, and then plus 1. I'm going to put 2 over n at the front. It's getting confusing. Too many n's all around the place. Okay, now we need to evaluate this. So we have 2 over n at the front. We need to expand that. Right? So we're going to get 1 plus this times by 2, so 4 over n I minus 1 plus 4 over n squared I minus 1 squared, right? Plus another 1. It's going to add that to the front and get 2. Okay, distribution time. So we get, right, distribution, you get 4n, so that 2 times 2, because a constant, you just bring it out to the front. 4n and I over 1, 1, plus this times this gives you 8 over n squared with sigma of I minus 1. You agree? Okay, lastly, you get 8 over n cubed sigma I minus 1 squared. Okay, this first sigma is just going to equal to n, right? N times 1, n. Okay, so we get that. Okay, the second one here, we actually should do another distribution. Okay, there's 2 terms in there. And we get the following. 8 over n squared sigma I over, so you get I minus 8 over n squared with just sigma. Okay, I'm not going to write the I goes 1 to n from now on. This last one we actually need to expand, like I squared minus 2I plus 1. So actually let me just recap what we're doing, because I think we might be getting lost in the details, okay? I think actually maybe I should have just expanded everything in here and collected all the like terms first, and then separated the sigma. I separated it first. Okay, expanding, we get 4 So let's just expand it first here. 16 n cubed sigma I, and lastly minus 8 over n cubed sigma. Yeah, actually unfortunately it doesn't collect, so actually what I'm doing right now is pretty much the fastest way. Even if we simplified earlier, it wouldn't be any cleaner. Okay, so now we have to use this formula. That's over 6, and this formula. Okay, we gotta use those two. Okay, so the 4, you can just leave it at the front. 8, so limit 8 over n squared, it's n plus 1 over 2 for this. Okay, and this one, next one, 8 over 3 n plus 1, 2n plus 1 over 6. Okay, so this is not going to be as bad as you think. Okay, see this next one here? 16 over n cubed. I'm going to times that by n over n plus 1 over 2, right? If you take the limit of this, look at the degree. What's higher, on the bottom or top? It's going to approach 0. Next one, same story. The bottom degree is a lot higher, right? Next one's going to be minus 8 over n cubed times by n. Both of these guys you don't have to worry about. Okay, and then we also know from doing limits of a rational expression, it depends purely on the coefficients, right? That's going to end up being 4 when you take the limit. Here it's going to end up being 8 times 2 in the top. At the bottom, of course, it's just this is an n cube, right? So it's going to be 6 at the bottom, right? That's it.
Wow.
So it's 8 minus 8 over 3. So the area is 16 over 3.